Hello everyone, our lesson today is finding the limit of a function algebraically. Theorem, limit a polynomial function. If f of x is a polynomial function in x, then limit f of x when x approach to a equal f of a. Limit of the constant function. If f of x equal k, where k is a constant, then limit f of x when x approach to a equal limit k when x approach to a equal k. Theorem 2. If f and g are two real functions in x and limit f of x when x approach to a equal L and limit g of x when x approach to a equal m, where L and M belong to the real number. Then, number 1, limit f of x plus or minus g of x when x approach to a equal limit f of x when x approach to a plus or minus limit g of x when x approach to a equal L plus or minus m. Then limit of algebraic sum of two functions equal the algebraic sum of their limits. This rule can be generalized for the sum of finite number of functions. Number 2, limit f of x multiply g of x when x approach to a equal limit f of x when x approach to a multiply limit g of x when x approach to a equal L multiply m. Also, limit k multiply g of x when x approach to a equal k multiply limit g of x when x approach to a equal k multiply L, where L k is a constant. Number 4, limit f of x over g of x when x approach to a equal L over m, where m doesn't equal 0. Also, number 5, limit f of x power n when x approach to a equal limit f of x when x approach to a power n equal L power n, where n belong z plus. For example, example 1, find each of the following limits. Number 1, limit x squared plus 3x minus 2 plus 2x over x minus 1 when x approach to 0. Solution, limit x power 2 plus 3x minus 2 plus 2x over x minus 1 when x approach to 0 equal limit x squared plus 3x minus 2 when x approach to 0 plus limit 2x over x minus 1 when x approach to 0 equal limit x squared plus 3x minus 2 when x approach to 0 plus limit 2x when x approach to 0 over limit x minus 1 when x approach to 0 equals, by replacing negative 2 plus 0 over negative 1 equal negative 2. Theorem 3, if f and g are two functions in variable x and g of x equal f of x equal g of x for all the values of x belong to R except a, and limit g of x when x approach to a equal L, then limit f of x when x approach to a equal L. Example, find each of the following. Limit x squared minus 16 over x minus 4 when x approach to 4. Solution, let f of x equal x squared minus 16 over x minus 4 by replacing, then f of 4 equal 4 power 2 minus 16 over 4 minus 4 equal 0 over 0 unspecified quantity. Then limit x squared minus 16 over x minus 4 when it x approach to 4 equal limit and factorize x minus 4 x plus 4 over x minus 4 by canceling x minus 4 with x minus 4. We get that limit x plus 4 when it x equal 4 by replacing with it x equal 4, then we get 4 plus 4 equal 8. Number 2, limit x power 3 minus 8 over x squared minus 5x plus 6. Solution. Let g of x, f of x equal x power 3 minus 8 over x squared minus 5x plus 6. By replacing, we get 2 power 3 minus 8 over 2 power 2 minus 5 multiply 2 plus 6 equal 0 over 0 and specified quantity. Then, limit x power 3 minus 2 minus 8 over x squared minus 5x plus 6 equal limit when x approach to 2 and by factorizing we get that x minus 2 multiply x squared plus 2x plus 4 over x minus 2 multiply x minus 3. By cancelling this vector x minus 2 with x minus 2 we get limit x squared plus 2x plus 4 over x minus 3, and by replacing with x equal 2 we get that the limit of the function equal negative 12. Number 3, limit 2x plus 3 all to the power 2 minus 1 over x squared plus x. Solution. Let f of x equal 2x plus 3 all power 2 minus 1 over x squared plus x. By replacing, we get that f of negative 1 equal negative 2 plus 3 power 2 minus 1 over negative 1 power 2 plus 1 minus 1 equals 0 over 0 and specified quantity. Then limit 2x plus 3 all power 2 minus 1 over x squared plus x equal limit, and by factorizing the difference between two squares 2x plus 3 minus 1 and 2x plus 3 plus 1 and take x is common vector, then we get x multiply x plus 1. And by simplifying 2x plus 2 multiply 2x plus 4 over x multiply x plus 1. We get L2 common vector. We get that x plus 1 multiply 2x plus 2 over x plus 1. And by cancelling this vector x plus 1 with x plus 1, we get 4 limit 4 multiply x plus 2 over x when it x approach to negative 1, and by replacing we get the limit of the function when it x approach to negative 1 equal negative 4. Example. Find limit x power 3 minus 7x plus 6 over 3x squared minus 8x plus 4. Solution. Let f of x equal x power 3 minus 7x plus 6 over 3x power 2 minus 8x plus 4. By replacing, we get that f of 2 equal 2 power 3 minus 7 multiply 2 plus 6 over 3 multiply 2 power 2 minus 8 multiply 2 plus 4 equal 0 over 0 is unspecified quantity. Then x minus 2 is the common vector between the numerator and the denominator. By dividing the numerator by the vector x minus 2, because this factorization is difficult, we get the long division. We arrange this polynomial x power 3 negative 7x plus 6 divide x minus 2. We get the first term divide the first term x power 3 divide x equal x power 2, and by multiplying x power 2 multiply this vector x power 2 multiply x equal x power 3, x power 2 multiply negative 2 equal negative 2 x power 2, and by change the sign and adding, we get x power 3 minus x power 3 equals 0, and plus 2x power 2 minus 7x plus 6, and repeat this division. First term divide first term. 2x power 2 divide x equal to x, and multiply 2x by this vector. 2x multiply x equal to x squared. 2x multiply negative 2 equal negative 4, and change the sign, and adding 2x squared minus 2x squared equals 0. Negative 6x plus 4x equal negative 3x plus 6, and repeat this division. Negative 3x divide x equal negative 3, and multiply negative 3 by x equal negative 3x, negative 3 multiply 2 equal 6, and it changes the sign, and by adding we get 0, 0. Then the factorization of this polynomial equal x power x minus 2 multiply x squared plus 2x minus 3. Then we can write the limit as limit x power 3 minus 7x plus 6 over 3 multiply x power 2 minus 8x plus 4 equal limit x power x minus 2 multiply x squared plus 2x minus 3 over x minus 2 multiply 3x minus 2, and by canceling this vector x minus 2 with x minus 2 we get limit x squared plus 2x minus 3 over 3x minus 2 equal, by replacing 4 plus 4 minus 3 over 6 minus 2 equal 5 over 4. Example. Find each of the following. Limit x squared plus 2x over the square root of x plus 9 minus 3. Solution. By substituting in each of the two functions by x equals 0, we find that the value of each equals 0 over 0 is an specified quantity. And multiply the limit by the conjugate of the denominator, and we get that limit x squared plus 2x over the square root x plus 9 minus 3 equal, by multiply the conjugate, and we get after simplification limit of the function x plus 2 bracket the square root x plus 9 plus 3 over x plus 9 minus x, and plus x minus x equals 0, and cancelling x with x, we get that limit x plus 2 multiply bracket the square root x plus 9 plus 3, and by replacing we get that the limit of the function equal 12. Example. Find the limit of the square root 4 plus x minus 2 over the square root 9 minus x minus the square root 9 minus x. By substituting in each of the two functions by x equals 0, we get the value of each equals 0 over 0 is an specified quantity. By multiplying the conjugate of numerator and denominator, we have this form. And after simplification, we get that limit 4 plus x minus 4 over 9 plus x minus 9 minus x multiply the square root x plus 9 plus root 9 minus x over the square root 4 plus x plus 2. 4 minus 4 equals 0. 9 minus 9 equals 0. And after simplification, we get x multiply the square root 9 plus x plus the square root 9 minus x over 2x multiply the square root 4 plus x plus 2. And by cancelling x with x, we get that. And by replacing we get the limit of the function equal 3/4. Example. Very important example. If limit f of x minus 7 over x minus 3 when x approach to 3 equal 4, where f of x is a polynomial function, and the limit and find limit f of x. Solution. Since limit f of x minus 7 over x minus 3 when x approach to 3 exists and equal 4. That means the numerator equals 0 at x equal 3. And the numerator equals 0 at x equals 3. Then f of 3 minus 7 equals 0. Then f of 3 equals 7. F of x is a polynomial function. Then limit f of x equal f of 3 equals 7 when x approach to 3. Thanks for all.